look at the video that I posted this morning and or download the calculator program?
Not yet, but I want to do that once I get home with the calculator cable.
Okay, all right. And the test is tomorrow, because otherwise I would say you could come by my office and I could put it on your calculator, but I am not in my office right now. I'm at my brother's house, which means at some point my brothers are going to come home and the dogs are going to start barking, so just be aware of that. All right, so this problem says to use Thevenin's theorem to calculate V naught. So what Thevenin's theorem says is to to represent the rest of the circuit with a single voltage source and impedance, and then you can use that to see what would happen if you apply a load. So for Thevenin's theorem, if you don't have any dependent, well, no matter what, you need to get the voltage and the impedance. And the way to get the voltage is almost always with a V open circuit. And there are different ways to get the impedance. I think the easiest way is with equivalent impedance, because that's just, resistor simplification. But to get the V open circuit, first we need to draw what it looks like as an open circuit. And we're going to put the open circuit where the load is right now. So the open circuit is right there. So that's where we want. That was the first mistake I made the first time I did this. This is not a voltage source. That is a current source. This is a voltage source. And this is 10 ohms. This is minus J 15.9 ohms. This is 12 ohms. And this is 50 angle 0. All right, so I think the easiest way to get V open circuit is to realize, and then tell me if you see I'm making a mistake, is to realize that as this is an open circuit, the only current that's going to flow is going to be flowing through this loop right here. And so we know what the current is on this loop. We know the current is 2 amps down, 2 angle 0. So we can do a Kirchhoff's KVL around the outside loop, and this is plus minus, that's V open circuit, and that should get us the value of V open circuit. So this would be, did somebody say something? No, okay. So this would be starting right here. I'll have minus 50 minus V open circuit plus 2 times 10 minus J 15.9 has to equal 0. Does that look good to everybody? So minus 50 minus V open circuit plus 20 minus
what do we do with the 12 ohms?
Well, since KVL says you can do any loop, I'm just doing the outside loop. So you can do, KVL says you can do the outside loop or the inside loop or the other inside loop. So I chose just to do the outside loop, which does not include the 12 ohms or the current source. So I could do a KVL on this loop, I could do a KVL on this loop, or I could do a KVL on this loop. Now, it never helps you to do a KVL on every possible loop because you have a redundant information. But for this one, just one loop I think will do it. So now
I wasn't paying attention to that step where, the J. Isn't there some situations where the J disappears?
well, when you multiply a J by a J, that gives you -1.
Got it.
Because by definition, J is the square root of -1. So J times J becomes just -1. And so when you have a J times a J, the J will disappear. Okay, other questions? These have been good. All right, so now I have, let's see, when I'll take everything to the other side. So I have minus V open circuit equals, that's a minus 30, so when I add it, that's a plus 30 plus J 31.8. I think that's right. And so V open circuit equals minus 30 minus J 31.8. So did anybody see any problems with that? All right, and if not, let me go ahead and see what that is in polar. So minus 30 minus J 31.8. Change that to polar, and I get, oh hey, I got this number once before, so that's exciting. So V open circuit is 43.718 angle -13. Nope, -133.31 degrees. Okay, so now I need to get Z Thevenin. So to get Z Thevenin, I will deactivate my sources. And so my current source becomes an open circuit and my voltage source becomes a short circuit. And then I find the equivalent resistance or equivalent impedance of everything that's left. Now, I still don't have a resistor here because that's going to be my load resistor. Hold on a second. I'm actually online, so yeah. So I still don't have a resistor here because that's where I'm going to put my load. So that's why I didn't put that resistor in. So I want to find the equivalent impedance of everything that's left. So we see that we don't have any current going through this middle branch right here. And so the only impedance we have is the impedance over here on this side. So Z Thevenin is going to be 10 minus J 15.9 ohms. And I think I forgot to put my volts up here on my voltage. Okay, so now I have my Thevenin equivalent circuit, and so my Thevenin equivalent circuit has the voltage source of whatever I had. So my voltage source was 43.78 angle -133. And my impedance is 10 minus J 15.9. So that is my Thevenin equivalent with, let's see, a plus minus like that. And Now I want to find the voltage across the 5 ohm resistor. So I put a 5 ohm resistor right there. And now I can do a voltage division. And so the voltage across my 5 ohm resistor, so VO, will equal my total voltage, 43.78 angle negative 133, times, oh, and I wanted to get back to y'all about the current division, so I'm going to do that after I finish this problem. 5 over, and then I'll add the two impedances together, so that's 15 minus J 15.9. And let's see if by any chance this gets us the right answer. So it'll be times, and then 5 over 15 minus J 15.9. And that looks like it's going to be close. Second complex, change to polar. Hey, look at that. I finally got the right answer, like when I had an audience. That's why I need y'all to come to SI sessions. See, so I have, so V naught is 10 angle negative 86.7 degrees volts. Okay, questions on that?
How'd you know to move the 5 ohm resistor in series? Or actually, never mind, I guess I get it now that I just looked at the circuit.
Well, okay, but yeah, I'm going to go ahead and explain it though, because this is what Thevenin's theorem tells us. Thevenin's theorem tells us once we get V Thevenin and Z Thevenin, that our entire circuit looks like this. That is our entire circuit with V Thevenin and Z Thevenin, and then you put your load resistor right there, or your load impedance right there. And so that's why I did it that way. It was not because of, well, it was also because of how the original circuit was, because the original circuit, because the problem said to use Thevenin's theorem, I made my open circuit right there, and that's where I was going to put my load. And in this particular problem, the load was already drawn in, but it could have been like this, and with just the terminal AB, and then the problem would just say use Thevenin's theorem to calculate what V naught would be with a load impedance of 5 ohms, or any other load impedance. So does that answer that question?
Yes, it does. Thank you.
Okay. And if it was Norton instead of Thevenin, you do the same thing, except you get a current source and a resistor in parallel, and your load resistor goes in parallel. So that would be if for some reason it said Norton. But if I recall correctly, Professor Rabelais is not one of the ones who really likes Norton instead of Thevenin. Now, one thing that he does use that it depended on the professor. In circuits 1, we pretty much always used resistances, but you can also use conductances. And conductances are, conductance is 1 over the resistance, and you also have the admittance is 1 over the impedance. So you might see that as well. So just, that's something to be on the lookout for that's kind of different. Okay, so other questions on this? If not, I'm going to save this recording, and I'm going to talk to y'all a minute about current division.